the goal of this webinar is to really understand what exactly should you do to get a band of 7 and 8, and what really is the difference between a 5-6 band and a 7-8 band. Okay, because most students find themselves stuck in that 5-6 range and not really be able to get that 7 or an 8 on an average score on their science labs or whatever it is. And after that, so I'm going to go over certain common mistakes that students make, which really keeps them stuck in that 6 band and not really, go on to the 7. And for some sections, especially with your lab reports, which is where your criteria B and D are usually tested, we are also going to see what are the templates that you could use. Like, I'm already giving you a script. Like, oh, if you want to write your hypothesis, you could begin this way. Or if you want to write a research question, you could kind of put it in this specific format. So it's just to help you. And keep practicing this, and eventually you'll really get the hang of it, and it's really not that hard. All right. So criteria B, right? So does anybody wanna? If I'm asking a question, you guys can either put it on the chat. You can just put it on the chat, and I'll be able to see it. So will everybody else. So what usually when you have a test or a lab report due, right? What are the things that are usually tested in your criteria B? Anybody? Okay. So in your criteria B, what you're usually tested is, like, when you have a lab, you have to first start off with what is the question of your lab? Like, what are you trying to figure out by doing this experiment? What are you really looking for? That's the first part. And when you obviously begin something, you'll have some idea what the expected result is. That is what your hypothesis is. So you are essentially, before you begin your experiment, what you're trying to do is you're trying to look at, okay, what is the question I'm trying to find the answer to? What do I expect the answer to be? And in order to figure this out, how should I set up my experiment? What equipment should I use? And what are the step-by-step methods I should follow? This is what usually comes under criteria B. What they're testing for is, do you really know how to conduct an investigation, and what is the direction in which you should think before doing that? So the topic of our webinar is a science topic, especially specifically a physics topic, which is electricity. So I have taken the example of the electricity experiment, which is testing what is the result that you would expect in the resistance of a wire when you change its length. Okay, so when you are trying to figure out what are the differences, what will you see when you do this test, what are the step-by-step method that you're going to follow to do this investigation. So like I said, again, the first and foremost thing that you're tested on is how well have you phrased your research question. What is research question? The question that you're asking. What is the purpose of this particular experiment or investigation? What are you trying to figure out? How well have you phrased that? So we're going to go over a couple of examples of what's a bad research question versus what's a good research question. And once you have your question, you should have an idea of what your expected answer is. Now, when you do the investigation, you may find that your hypothesis was correct, or you may find that it wasn't. But in order to know that, the first thing you need is a testable hypothesis. And after that, you need to also explain with your hypothesis why you think so. There should be some kind of scientific backing to why you think that is the the hypothesis or the expected result. Now you're thinking, okay, when length increases, I believe that the resistance of that wire would also increase. Now, I can't just say that as my opinion. I have to be able to say that with some kind of scientific backing. So that is what a good hypothesis is, with scientific reasoning, and then the design of your investigation. So what we're going to go over right now is we're going to break all of these 4 sections in detail. Okay. I'm sure all the students here who are in MYP right now, whether you're in year 3, 4, 5, you guys definitely have had a lot of lab reports that you've turned in. And every lab report, you've seen these common words that I've just talked about. So we're just going to go over what is like the best way to phrase your research question, right? So these are the 4 things that your research question should include. So like I gave you the example, like when you, okay, can somebody tell me what actually happens when you change? I think this is more of a question to my MYP 4 and 5 students. What happens to resistance of the wire when you change its length? So the research question, before we get into that, so when wire length, thank you for the answer. When the wire length increases, usually the expectation is that resistance increases. So research question is not a statement, it's a question, right? So you have to ask, what happens to resistance when the wire length increases/decreases? So if you look at the 3 examples I have given you here, first one is very obvious. We all know, how does wire change electricity? Now that doesn't make any sense. That's a very weak question. That question has no meaning, quite literally, okay? Most students end up writing the question like something in the middle. How does wire length affect resistance? That's exactly what I just said too, right? So that does make sense. How does wire length affect resistance? But you're not going to get a 7 or an 8 if you phrase it this way. So what is the difference between the second one and the third one? The third one, that's a strong level 7-8 research question. So there you have your independent variable. So independent variable is the variable that is changing. In this case, the resistance is your, independent variable in this particular case would be the length of the wire. Dependent variable is the resistance, because resistance changes depending on the length of the wire, which is the independent variable, okay? So both the dependent and independent variables should be there in your research question, which is there in both of these options. But the last one includes, it has specific detail that in your experiment, you're using wires between the lengths 10 centimeters to 50 centimeters. That's written there. Also, how the measurement is done, how are you really measuring it, okay? So a strong research question, any basic research question is supposed to have independent and dependent variable. And sometimes you can even add control variables if relevant. In this, you could add, how does increasing the length of a nichrome wire, 10 centimeter to 50 centimeter, affect its electrical resistance when temperature and area of cross-section are kept constant? So you can add that. Or you could put it this way of like how it's measured versus what the range of the length would be. Did that make sense? Does anybody have any questions? Feel free to put it on the chat and I'll answer any questions that's there. All right. So moving on, this slide is just explaining a little bit in depth about what the difference between an independent variable and dependent variable is. So I actually have another slide with a couple of questions that's going to clear this up. So why don't we go through this? So what's happening on this slide is, question number 1, how does a temperature affect the rate of reaction between hydrochloric acid and magnesium ribbon? So when you read this, I want you to tell me What part of this question is describing the independent variable and which one is describing the dependent variable? Any volunteers? Anybody wants to answer this question? Thank you, Vehan. Independent variable is the temperature. Dependent variable is the rate of reaction. Very good. So rate of reaction is obviously changing depending on the temperature. So that's exactly what it is. So now this question doesn't have any controls in this. Now this question is a decent research question, but it's not entirely great. You can say that you have to add some extra specific details to make it a better research question, okay? So let's kind of quickly run through this just to understand the difference between independent and dependent variable. Question number 2, what's the answer? Right. Dependent variable is light intensity, dependent is rate of photosynthesis. Good. Students that are genuinely participating, you guys can unmute and speak as well if you are if you have any question or anything that is very pertaining to what we're talking about here, okay? Right, so let's do question 3. Great, good job. So now these questions are a little easy because they're all phrased in the same way of like, how does the length of the pendulum affect its time, blah, blah, right? So I have a few more questions later on that are slightly more different. So we'll look at that too. So now this is your take-home message that this is what I have to offer the students. When you're writing a research question for any experiment or any lab that you have, any investigation coming up, write it in this format. If whatever is your independent variable in your question. Does somebody want to tell me a recent experiment that they turned in any of the MYP classes? Oh, yes, Vihan, you are correct. You're correct. This is the template for hypothesis. I think I mixed up the slide. Thank you for catching that. Thank you for catching that. But we can use this still for the research question. I'll tell you what the research question will be. It's the same thing. You can just write it as, how does the dependent variable, please write down what I'm saying, okay? How does the dependent variable change when the independent variable changes while the controlled variables are kept constant? Did you guys catch that? How does the dependent variable change if the independent variable change when the control variables are kept constant? So for whichever experiment you have, you would be writing whatever dependent, independent control variables pertaining to that, okay? Can somebody tell me a recent lab or something that you guys have done? Something that you just turned in, the topic of the lab that you just turned in. Nobody? Come on, guys. There are some active participants here in the chat. Help me out here. Vihan, you want to tell me an experiment that you turned in? Okay, electrolysis. What was your research question? So, okay, I have 2 people here that told me your experiments. Why don't you guys also type what your research question was? It doesn't have to be perfect, just a rough idea. Why don't you type that research question in the format that I just told you? Or you can unmute and say that as well. Okay, so how does the concentration of copper sulfate affect the rate of copper deposition while keeping temperature constant? Exactly. Now, that is a very good research question, okay? How would you make that better? What I would do to make that better is I would add maybe copper sulfate, what was it, solid, aqueous, you would talk about that. And you can say rate of the copper deposition measured in what units, you could add that. Or you could also add how did you measure it? How did you measure did you use like a digital timer? Did you use, or what was the range of the concentration that you used? Okay. How does the concentration between like 5 to 10 of copper sulfate? You could add something like that to make your research question better. Now, you can confidently add that because adding that additional specific information, as long as information you added is correct, no teacher will dock points off of that. But if I want to be a strict grader, I can knock off your points if you didn't put that in. Okay? But this is a pretty good research question, the way you typed. I would probably give you a 6 or a 7 for it. But to get that 7 or an 8, you need a little bit more specificity. All right. So moving on. Hypothesis. So my previous slide, there was a mistake there. That was the template for a hypothesis, actually. And it's quite clear. It's very similar, right? So you are essentially answering your own research question. Now, this is just a prediction based on the scientific theory that you have, okay? So if you read the example in blue, that makes the most sense. If the length of the nichrome wire increases, aka the independent variable changes, then its resistance, the dependent variable, will increase proportionally. And always there should be a because and a scientific specific line that you either found in your books, your class PowerPoints, or on your Google research. Because here, according to this particular formula, or according to this particular theory, or according to this particular scientist, you should have that. Without, see, as length increases, resistance increases. Is that correct? Yes. That's a 3 or a 4. That's not a 7 or an 8. Why? Because it's lacking scientific reasoning. Cool? So let us move on. Method, I don't really have a lot to explain. The only thing is, whenever you write your method, obviously, it has to follow a logical sequence. The thing you shouldn't forget is, please do not forget at the end, last step, to be like, repeat the trials 3 times or 5 times or whatever, and also write what are the safety considerations that you have to make. So, and when you're writing, oh, please heat water in this, or please cut a wire and run it, you have to write specific measurements of everything. If it's a wire, its length. What are the 3 different wires you used? What are the lengths of each one of them? If you were heating water, what was the weight or what was the quantity of the water? So I have always seen this whenever students turn in their labs, that many of them forget to write how many trials they should do, or just mentioning trials, period. They do the calculation related to trials, but when they write their step-by-step methods, they never write, repeat the experiment 3 times with wires of different lengths. They never write what is the quantity. Now you said, how is the concentration of, you were doing the copper sulfate one, right? So at each and every step that you did, what was the quantity of the copper sulfate you used is very, very important to mention. Any questions? Okay, let's move on. So with criteria D, for the sake of time today, I'm going to have to run through it a little bit faster. But the summary of criteria D is, so you go B, C, and then D. So C is not the topic today, but basically C is where all your calculations, your graphs, and all of that go. Then you move on to D. D is where, okay, now you've already designed your experiment. You've already done it. You have seen your results as well. So now criteria D is about taking your experiment outside of your books and into the real world, okay? You're looking at it like, oh, but when this experiment is done, how does it affect me? Why does this matter? Why does the concentration of copper sulfate affecting its reaction rate and electrolysis a big deal to me? Why do I care about electrolysis? Vihan, why do you care about electrolysis? No, do you regret answering because I'm picking on you and I keep calling you for every question? Somebody else wants to answer that question? No, he does enjoy answering it. Good. Exactly. The applications of it, right? So criteria D is something you get points in only if you're able to very well explain why this experiment matters. Why it's not like why does this experiment matter? It's more that what your inferences, what did you learn from this experiment and where can you use it? And you're not going to get the right points if you're going to be vague about it. Okay. So now here, these are the three questions you have to keep in mind when you're answering. So there's your discussion and there's your evaluation. In your discussion section, you're probably just kind of explaining why it's important. In your evaluation, you have to talk a little bit more about what was good about it, what was bad about it, and how can you improve it. These 3 points come in the evaluation section. Discussion is you just explaining what various applications of this of the things you learned from that experiment is. Okay. So how does the scientific concept or investigation how is it used in your real world is the question you should ask first and try to formulate the answer to that. Then you look for very specific applications of it. Like here, you said electroplating, something like that. Then we have to write, why is this important? Because now, for example, through like an experiment, if I found a way to like reduce the temperature of something that's of like, or if I'm able to reduce the amount of carbon dioxide that is emitted in an experiment, I can write this matters. Why? Because it's going to help our climate crisis. So something like that is how your discussion should be concluding. Okay. So here's a great example. It is saying that, okay, it is essential in electrical wiring systems because our resistance, and it's talking about energy loss as heat. And you can always talk about cost in many of these things. That's another hint that I could give you. Okay. You can't just write, oh, electricity is important because I need electricity in my house. No, not like that. It's more about how does it benefit you and the rest of the world. Okay. Let me. Yeah, so there's another example. You guys are free to like read that. And every point you write, of course, should be scientifically backed. So evaluation, this is important too in evaluation, especially point number 3. Don't write, these are the advantages of this bit using, like, for example, we were doing something about nichrome wire. So you don't write like, oh, nichrome wire is good because it does A, B, C, D, E. And it's bad because it costs this much, or it's causing like its conduction is this way, whatever. And don't write them separately. Your evaluation should always be like, oh, while this, and this is good about it, the problem is this. Next sentence should be, so maybe we could improve it by doing something else. Is that making sense? Now, whatever your purpose in an evaluation is to evaluate both sides equally, okay? And kind of understand why you do have to write, you have to list advantages and disadvantages. Just kind of write them together. Don't write them as separate lists. And don't write which is it better to do it or not better to do it as your personal opinion. Just make a very scientifically diplomatic statement. So, and I'll show you examples of what I mean when I say that. Right, so here it's telling you, so this is a good template. This is a good template, okay? You can write while one part of the experiment, in this case, using thicker copper wires is giving you this benefit. It may also lead to blank. So here's where you write the disadvantages. So in evaluation, you start off with your advantages, but then you also compare it to the disadvantages. And then you say, so when we make a decision on which wire to use or which particular substance to use in my electrolysis for making batteries, we must consider ABC because we are talking about what are the benefits, but we are never forgetting to mention what the limitations we have are. Then your second paragraph of evaluation could be you suggesting improvements. What could we do to fix this limitation? What is another alternative? Or what could I change in my experiment, which is where you write, if you have a testable extensions section, you could write that there, where you write, what could I do to change in this experiment so that I'm a little bit more informed and I could find something else out. Right. Okay. This is all some basic stuff like don't stay vague. Talk about both sides. Like don't talk only about advantages a lot or disadvantages a lot. Talk about both sides equally. And once you have listed both of them out together, in the end, you should give a balanced reasoning of what's what. Okay. Cool. So these are some questions asking you like, what is a good research question? What is not? So your goal should be, what is the best answer if you want to get like a 7 or an 8? So please take your time, read this question, and we'll do a few questions. And with that, we'll conclude the session. Okay, Jasmine thinks it's C. Anybody disagrees with her? It's pretty straightforward, right? What is missing in A? Why is A not that great? So A just doesn't give you, it's missing how it's measured, good. Or it's missing details, it's missing specifics, right? Number two. Okay, number two, we have already looked at independent and dependent variables quite a bit. Let's do number three, question number three. Now, question number three is a little bit of a question to maybe MYP 4s and 5s, not to my 3s and 2s. So if you're in your year 3 or 2, don't worry if you're not understanding question number 3. Nobody knows? It is the wire material. Good job. Because think about it, okay? If I measure the resistance with a nichrome wire, then after that I take a copper wire and I compare it, it doesn't tell me anything about length because the resistance probably changed because the material is different. So you have to control everything else that could affect the resistance. So when you're your goal is to only look at, is the wire length changing the resistance or not? So if I have something else that's also affecting the resistance, my result won't be specific to wire length, which is why I have to control all other things that could affect my results. That's how controlling works. Wait. Question 4. Question 4 is pretty straightforward as well. Good. It's C. We've already gone over this, so unless anybody has a question, I'm going to move on. Right. Question 6. So investigation plan could also mean method. Okay. So that's what this is asking about. Good. So question number 6 is B. So you have to record more than one trial. You have to talk about, so mentioning the repeating trials is extremely important. That's the purpose of this question. Question number 7. So question number 7 would be your criteria D, asking about application. What do you think the answer is? Great. C. So let us do question 9. So answering this question is pretty straightforward. I just want you to recognize anybody has an answer for question 9? D, exactly. So here, if you see this, the way to write evaluation is while thicker wires reduce resistance. Now that's listing an advantage. And improve efficiency. That's another advantage. Now we're talking, but the problem is they increase cost and they require more resource extraction, which are both disadvantages. So we should consider balancing the efficiency with sustainability. When you write, now this is a conclusion sentence to your evaluation. The earlier lines could be you exploring a little bit why and how it improves efficiency, what are the disadvantages, what are the advantages, and then your final evaluation sentence is something that should look like option D. These are all, quite honestly, a repeat of the same thing. So let's do question 11. Good. It's pretty straightforward. It's not that complicated. So in order to, I think I'm going to conclude this here. So what I have here is that, I mean, if you guys are allowed to, you are free to take a picture of this if you would want. What's happening here is that this is an example of a report that's written here. And actually, we can do this quickly. I'll give you guys a minute or two. Just take a look at it and tell me, if you were the teacher, what grade would you give this? Would you put this in a 3-4? Would you put this in a 5-6? Or would you put this in a 7 or 8? Come on, nobody wants to take this up. This is fun for you. This is what your teachers do to you, right? They grade you. You grade the student. Tell me. Okay, Jasmine thinks it's a 4 to 5. Anybody else? What do you guys think? No, nobody else wants to grade her? If there's no time, why don't you guys just read the research question and based on that, okay, research question is incomplete, cool, does not have manipulation of variables and the control variables are not mentioned, very good. Hypothesis has limited scientific reasoning, very, very good. So you would give it a 5. Exactly. So I agree with both of you. Me grading this, I would probably give it a 5. If I was feeling very good that day, maybe I'd give them a 6 because their method looks good. Variables are mentioned well. But yeah, but 5 is an appropriate grade for this, right? And my next slide was going to be about what are we missing. And Vihan already has everything. So they have a research question, logical hypothesis, variables are there, method is good, repeats are included. But like you said, the controls are not mentioned properly. The depth of the scientific reasoning is not good enough, and there is no specific details in the research question. It's clear, but it's not enough. That is it. So this is simply the same exact experiment rewritten, and this is what you should write it as in order to get a 7 or an 8 and not a 5 or a 6. So it's the exact same thing as what was on the last slide, but I have written it with all the details that it was missing. So that is all I have for you today.